First part of the review here is non-calculator, so keep that in mind when solving these. This will be on the non-calculator part of the test. So we are on 1 through 4 looking for this missing side over here. I'll call it x. Remember on 8.1 we learned how to rewrite exponentials as logs and logs as exponentials. So that's what I'm going to need to do here is rewrite. So I'm going to take this exponent, which is 3 log 5, and I'm going to set that equal to log, and then my base, b here, would be my base from the exponential, which was 10. So I'm going to have a base of 10 here, of the other side, which was x. Now my understood base over here is also 10, and remember when we have a coefficient like this 3, we can rewrite it as an exponent. So really I have log base 10 of 5 to the third equals log base 10 of x. Now I can mark out my log base 10. I'm left with x equals 5 to the third. 5 to the third power is 125, so x is 125. Same thing for number 2. I'm going to set this equal to x. Like I said, when we rewrite, this, our exponent, is this side of our equation, so 3 ln of 5 is equal to the log, in this case we're doing the natural log, of our base, which is understood to be e, since that was our base over here, of the other side, x. So here, again, I can make this an exponent, so this would be 5 to the third equals x, because our natural logs should cross out. This was an understood base of e as well. And again, 5 to the third is 125. All right, same idea here. This is my exponent, so I'm going to have 1 plus 2 log of x equals log base 10, so you don't have to put the 10 since that's an understood base, of the other side, x. All right, so remember here that both this piece and this piece were both 10 raised to that power. So I'm actually going to keep that in mind whenever I'm dealing with these two pieces. This 2 I can bring to the exponent. So I'll have log of x squared equals log of x. But then I still have this 1, which originally was 10 to the first. Well, again, our logs will cross out here, and I'm going to be left with 10x squared. All right, for number 4, same thing. So kind of like I did my 1 really meant 10 to the first, I'm going to have e to the first. And then with our exponents, remember that addition means multiplication, just like over here. I kind of changed to multiplication. That's how I had 10 times x squared there. So I'll have times e to the ln of x squared. I'm going to take that 2 and make it an exponent. Okay, so really, if I were to rewrite this natural log here would cross out with the natural log on the other side. So basically this goes away, kind of like it did over here. And I'm left with just e and my x squared. My e here and my x squared here, because this part crossed out. So I have e to the x squared. All right, for number 5. On number 5, again, I'm just going to rewrite. This time, my log is being rewritten as an exponential. So remember, my base is 2 raised to the 0 power equals 2x minus 5 over x plus 3. Anything to the 0 power is really just 1. So 1 equals 2x minus 5 over x plus 3. So I multiply both sides by x plus 3. So now I have x plus 3 equals 2x minus 5. And I get that x equals 8. All right, for this one, I've got subtraction, which I can rewrite as division. So I'm going to have log base 3 of x squared minus x over x squared plus x equals 1. And now I'm going to rewrite it like I did number 5. So my base 3 raised to this exponent equals this. So 3 to the first equals x squared minus x over x squared plus x. Again, I'm going to multiply both sides by that denominator. So over here, I'd have 3x squared plus 3x equals x squared minus x. So I would subtract x squared, which would leave me with 2x squared, add x, which would give me 4x, equals 0. So in both of these terms, we have at least 2x, so I'm going to factor that out. That would leave me with x plus 2 equals 0. So I have 2x equals 0 and x plus 2 equals 0, which is going to give me 0 and negative 2. So I go to check my answers, and my negative 2 works, so I have x equals negative 2. You also could simplify earlier in the equation, so here I could have taken out x from both. Our x's would divide out, and then I would actually have only had to set this equal to 3, which would only give me the negative 2. All right, for number 7. On number 7, I can rewrite my base of 4 over here as 2. So I'm going to write that as 2 squared, still raised to the 2 plus x. When I have power to a power, I multiply. So I'm going to have 4 plus 2x. So I'll have 6 minus x equals 4 plus 2x, which would give me 3x equals 2. So I'm going to have x equals 2/3. All right, here, addition can be rewritten as multiplication. So I've got log base 5 of x times x minus 4 equals 1, and I rewrite. So I'd have 5 to the first equals x squared minus 4x if I were to actually multiply and distribute there. So I move the 5 over. I got x squared minus 4x minus 5, which I can factor. That'd be negative 5 and positive 1, which is going to give us 5 and negative 1. And then I'm going to go and check those solutions. So I can plug 5 in here. 5 minus 4 is positive 1, and I can plug 5 in here. That works. But I cannot plug in negative 1 here or here because then I'd be taking the log of a negative. So only the 5 works. For number 9, we got addition, which is multiplication. So x times x minus 6. And then I got subtraction, which is division. I'm going to go ahead and make that 2 an exponent as well. So divided by x squared equals 1. Oh, actually, can't do that. Just realize that those have different bases. Try that again. Okay, so I can rewrite that first part. I can keep my log base 3 of x times x minus 6. But here we had a base of 9, so I'm going to have to do that change of base formula, which is 2 log of the base I want, which is going to be 3. And then you keep your m on the top. And then I write that log base 3 in the bottom. and I put my b in the bottom, which is the 9, equals 1. All right, so I've got log base 3 of, I can distribute this x, that'd be x squared minus 6x, minus right here, I can't do anything in the top because I have a variable, but right here I could ask myself 3 to what power would give me 9, and that'd be 2. So this would become 2 log base 3 of x over 2, and those 2's would divide out. And then I got log base 3 of x squared minus 6x minus log base 3 of x, which I can rewrite as division. So I would just have my x in the denominator. Well, both of these have a term of x in them. So I could say this would be log base 3 of x times x minus 6 over x. Those divide out. Again, this is always equal to this 1 over here. And then I can rewrite. This to this power should equal this. So 3 to the first equals x minus 6. So I'd have x equals 9. I'm plug 9 in here, and I'm good. And here as well. All right, here we are to graph our log x minus 2 plus 3. All right, so a few points that we should know would be on the graph of y equals log base 3 of x without any changes made. Okay, so we know if I were to plug in a 1 here, so I'd have 3 to what power, right? 3 to what power would give me 1? Well, that'd have to be 0. All right, let's say I were to plug in a 2 here. That wouldn't work. Nothing works out perfect. So let's say I do a 3. 3 to what power gives me 3? 3 to the first power gives me 3. Okay, the next number that's going to work out nicely would be 9. So 3 to what power gives me 9? That'd be 3 squared, which would be 9 too. All right, but we said we want to shift 2 units right. So that means I'm going to add 2 to all of these x values. And I'm going to shift 3 units up, which would mean to add 3 to all of these. So I'm going to plot a point at 3, 3, at 5, 4, and at 11, 5, which would be a little bit off our graph over here, but would fall right about here. So my graph would look something like this. So you can tell we're not going to cross this line. So my domain is from that asymptote to the right, so x is greater than 2. My range is going to be all real numbers because I'm going up and down. And then that asymptote is going to be at 2 because we said we can't go past 2. All right, next section is calculators. So these you would plug into your calculator to get your final solutions. All right, so here, if I was going to solve, I want to get rid of this 5. So I'm going to divide both sides by 5. So now I got 2 to the 3x equals 8 over 5. Of course, I would love to get a common base like we did on that front page, but there is no way to get a common base here. So my only option is to take the log of both sides. So I'm going to take a log over here, and I'm going to take a log over here. Now, while I'm at it, I'm going to go ahead and make this exponent a coefficient. So I'm going to pull my 3x to the front, and I'll have my 2 here. This one did not have an exponent, so nothing to pull to the front, so it'll just be log of 8/5. All right, and I'm trying to get x by itself, so I'm going to divide by the 3 so that these will divide out, and I'm going to divide by log of 2 so that these will divide out. So I've got to do the same over here on this side. And I would just type this into my calculator to get my solution for x. So x ends up being 0.226 if we round 3 decimals. All right, for number 12. Same idea for number 12. I'd love to get a common base, but there's no common base between 5 and 3, so I'm going to have to take the log of both sides. While I'm at it, I'm going to go ahead and move those exponents to the front like coefficients. So I'm going to have x minus 2 log of 5 equals 3x plus 2 log of 3. All right, so I want to get x by itself, so I need to get rid of this parentheses. So I'm going to have to distribute my log to both pieces to drop the parentheses. So I'm going to have x log of 5 minus 2 log of 5, and same thing over here. 3x log of 3 plus 2 log of 3. All right, I'm going to move all the x's to the same side, so I'd have to subtract 3x log 3 from both sides and add 2 log 5 to both sides, which is going to give me x log 5 minus 3x log 3 on this side. And then I'll have 2 log 3 plus 2 log 5 over here on this side. Now both of these terms have an x in them, so I'm going to pull it to the front, which would leave me with log of 5 minus 3 log of 3 equals 2 log 3 plus 2 log 5. And now to get x by itself, I would just divide by log 5 minus 3 log 3. And I'd do that on this side as well. And then I would just type that into my calculator to get my solution, which is going to be x equals negative 3.212. All right. For number 13. Number 13 says, on a college campus of 5,000 students, one student returns from vacation with a contagious flu virus. The model for the number of students n of t who will be infected with the virus after t days is this equation right here. So we don't even have to pick an equation, they gave it to us. Determine the number of days it will take for a minimum of 2,000 students to become infected. So 2,000 is my outcome, right? So I'm going to go plug that in on this side over here. So I'm going to have 2,000 is equal to 5,000 over 1 plus 4,999 e raised to the negative 0.8t. All right, so I am trying to solve here. So I am going to put this over 1, and I'm going to cross multiply. So I'm going to have 5,000 equals 2,000 times 1 plus 4,999 e to the negative 0.8t. But I don't want to keep that 2,000, so I'm going to divide both sides by 2,000. So that'll divide out. Now I'm left with 2.5 equals 1 plus 4,999 e to the negative 0.8t. And then I'm going to subtract 1, which will leave me with 1.5 equals 4,999 e to the negative 0.8t. And again, I'm trying to get t by itself. So now I'm going to divide by that 4,999. So that'll divide out. And now I've got e to the negative 0.8t is equal to 1.5 over 4,999. All right, t is in an exponent. Definitely not going to be able to get a common base here. So just like on the two problems we were doing on the page before, I'm going to have to take the log of both sides. Now, because I have e, I know I'm going to take the natural log of both sides. So this will be ln of e to the negative 0.8t equals ln of 1.5 over 4,999. Okay, so I can take this exponent and pull it to the front. So I have negative 0.8t ln of e equals ln of 1.5 over 4,999. Well, remember, ln of e is equivalent to 1. So now to get t by itself, all I'm going to have to do is divide by negative 0.8. And then I'm just going to type that into my calculator. So when I do that, I'm going to end up getting 10.139 days as the amount of time it would take. All right, for the next couple of questions, they give us the formulas here, and just like it says, these formulas will be provided for you on the test. You just need to know how to use them, when to use which one. Number 14 says, how long would it take for $100 to become $1,000 if it is invested at an 8% and compounded annually, quarterly, and continuously? So we're going to have to do all three. All right, if we are compounded annually would mean once per year. All right, so we have the initial amount and we have the final amount. We have the rate and we know how many times a year. That would be this formula because N tells us how often per year. So I'm going to have 1,000 is equal to 100 times 1 plus our rate, which was 8%, which would be 0.08 as a decimal, over number of times per year. Annually, we said means once a year, raised to the n times t. Well, n, we said was once a year, so this would just be 1t, or t. Now I'm trying to solve for t, so I'm going to try and get t by itself, so I'm going to divide both sides by 100, which is going to give me 10 equals, in here, 1 plus 0.08 is just 1.08 raised to the t. Okay, I'm not going to be able to get t by itself as it is because there's definitely not a common base there. So again, I'm going to have to take the log of both sides. So log of 10 equals log of 1.08 to the t. But while I'm at it, I'm going to go ahead and make that t a coefficient and move it up here. So I'm going to divide by what I want to get rid of, which is log of 1.08. So t would equal this, and I would just type it in my calculator. I'm going to get 29.919. All right, here, quarterly. Quarterly would mean 4 times a year. So, same formula, 1,000 equals 100 times 1 plus 0.08, but this time divided by 4 raised to the 4t. So again, I'm going to divide by 100, which is going to leave me with 10, and I'll have 10 equals 1 plus 0.08 over 4 raised to the 4t. Again, I'm not going to be able to get a common base, so I take the log of both sides. So log of 10 equals log of 1 plus 0.08 over 4 raised to the 4t, or I can go ahead and pull that 4t to the front. And then I'm going to divide by everything except t. So I just type that into my calculator, and I end up getting 29.069. All right, then finally for compounded continuously, remember that's its own separate formula. So that's this one over here, which would be your final amount of 1,000 equals your initial amount of 100 e raised to that rate of 0.08 times t. So again, I'm going to divide by 100, which would give me 10 e to the 0.08 t. Again, can't get a common base, so I take the log of both sides. Because it's an e, I'm going to take the natural log of both sides. And while I'm at it, I'm going to go ahead and make that an exponent. So let me scoot that over a little bit. Make that exponent a coefficient, I mean. So I'll have this here. And remember, ln of e is actually just 1. So all I have to do is divide by 0.08. Plug that into my calculator, and I get 28.782. All right, for number 15. Number 15 says if 7 grams of an isotope of the element instantinium decays to 4.023 grams in 16 days, what is the half-life? So our half-life equation would be the second one from the box on the page before. So our final amount in this case, it says, is this. This is what it came down to. And that should be equal to the initial amount, which was 7, times your base, which is going to be our half-life. And then we raise that to t divided by k. So t, in this case, they said was 16 days, but we're looking to figure out what k is. So this would be over k, and now I've got to solve for k. So now that I have my equation set up, I'm going to divide both sides by 7. So 4.023 divided by 7 is going to be equal to 1/2 raised to the 16 over k. So again, I would love a common base, but it doesn't look like that's going to happen here. So I'm just going to take the log of both sides. Now I am going to need to pull that as a coefficient. So I got log of 4.023 over 7 equals 16 over k times log of 1/2. All right, and I don't like that I have the k in the denominator here. So to fix that, I'm going to multiply both sides by k, which would make these divide out, and now I have k times this log over here on the right. So in order to keep k by itself, I now need to divide by log of 4.023 over 7 on both sides. So I would just type this into my calculator, and I'm going to end up getting 20.023 days. All right, last one. Solve using your graphing calculator. So remember, the way we do this is I'm going to put each side in my calculator. I'm going to put this in y1, and I'm going to put this in y2. Okay, once I do that, I know x squared makes a parabola-like shape, and that e to the x is going to make something that looks kind of like this. All right, so it does appear that they do intersect right here at this particular spot. So I just use my calculator to find that spot by pressing second, trace 5, and then you just press enter 3 times. And it's going to give us that intersection value to be negative 0.703.